Domain 6, security assessment and testing. This is actually one of my favorite topics because I kind of do a lot of this in my day-to-day job. So I get to review the content here. You know, maybe there are things that I forgot. I get to remind myself or do a little bit of research. So for the ISSA-2, there are like there's three ways in which they separate the content. It's around security testing, assessments, and audits. So I tried to put in the slides like the differentiator so we would know when we're switching between topics. However, it's a little bit confusing because then the whole topic of different types of assessments, vulnerability assessments, code assessment, is kind of independent. So I really just kind of tail off the rest of the deck talking about different kinds of assessment concept. This is very heavily a concepts presentation. And the exam content is very content-oriented. It's very concept-oriented. So security testing, a couple slides here. Security testing, basic thing is, you know, it's either manual or automated. So automated could be occurs on a scheduled basis or occurs after an event. The key thing I wanted to differentiate here is the idea of continuous versus automated. So there is a conceptual idea of continuous assessment or continuous auditing or continuous whatever. Usually when you see that, it's not referring to things that are just rote automated, but it's more of a concept wrapped around the idea of a methodology for continuous improvement. So when you see continuous assessment, it's not just that the automated thing runs all the time, it's that somebody is continuously improving it or expanding its scope or adjusting it to risk. Right? So continuous assessment is a slightly different concept. And you might often see this linked to something that says something around culture or practice, right? So security testing factors. Know all of these terms. The factors for security testing are the available, they're talking more about the object that you're testing, the availability of test resources to test that object, the criticality of the thing being touched. So you'll hear concepts in IT and security about, oh, well, we don't do this on production systems, we only do it on non-production systems. It doesn't necessarily mean that you don't do security testing against production systems. It means that you might do something different. So in a non-production system, you might do something more invasive. In a production system, you might do something that is more verifying the implementation of controls and verifying that systems aren't misconfigured or services aren't misconfigured. One of the testing factors involves the sensitivity of the thing that you're testing, right? If you're testing something that could potentially be damaged and it has an outcome, you need to know that when you implement the testing protocol. You're looking for misconfigurations. What is the likelihood of a misconfiguration on the target? What are the risks to the system? When you design a testing program, it should factor in what are the risks to the system. If you are very sensitive to denial of service, then you want your testing to verify that you have the right controls in place to prevent a denial of service attack. And you'd want to automate that. What is the rate of change in the environment or controls? So in virtually every regulatory framework, there's something that talks about change. So in PCI, for example, if you make a major change to a system, they want you to do a pen test again because things have changed. And the best way to identify if that change compromised the security control or drew risk to the platform that changed is to execute a pen test against it again, get a new result. Then with testing, you also have considerations around the time involved to test it and the difficulty. So you would change your testing program for certain things. It may be very expensive to do it, and it may take a lot of time to do it. The best example I can think of is when you're testing code that you're deploying into production, you may be able to verify things that are in text. Like the concept is called linting. So if your code it's written in a particular way, people write tools that will look at what you wrote, and they'll say, hey, I recognize that. That's a bad idea. Here's a suggestion to fix that. When you're testing an application and it's in a build process or it's in a pipeline, So your application is going from code to running on a continuous basis, or it's being built automatically. You can do things like linting in the pipeline to find security issues. Or there are some activities where maybe after your code is running, you want to test maybe the application itself in a running state. That may take too long. So you would have to change the way you test that application, not do it at the same time, because you can't do it at the same time, because it takes too much time to do it. You might schedule it to occur the weekend after a change, right? All right, so security assessment topics. I tried to highlight the key words here because it communicates a concept. Comprehensive internal reviews. Security assessments are, when you think of internal, it's internal to the people that are running the thing, right? Not internal company employee versus non-company employee. But like if my team produces an application, internal would be we're testing our stuff. So internal reviews of people, process, and technology, evaluating threats, risks, and controls for a protected asset or process. You're doing it so you can improve the testing, so you can cover additional features, so you can test different scenarios, right? So security assessment, we're differentiating that from audits. So the audit concept is that somebody is coming to verify that those controls are in place. They're not necessarily verifying doing improvement on it, but the audit typically tied to something else, an internal standard or an external standard, and they're external to your work group. They could be another organization within your company. They could be a completely outside entity. So that's the differentiation between assessment and audit. You want to be really clear on that one. NIST 853A. I'd suggest for some of these NIST guides, you can skim them. So I wouldn't read them in depth. It will make you fall asleep. But you can read them like at a high level, skim through them, sometimes looking at their appendix, look at their index, look out key concepts. In particular for this one, note that NIST 853 works around the concept of specifications, mechanisms, activities, and individuals. And I tried to give the briefest kind of description of what those four are. Oh, look at that. I even included an entire slide. There are sometimes bugs in these slides, okay? Just so you know. All right, now we're on to audits. An assessment done by an independent, not an external company, could be your own company, but independent to whoever is actually owning that system. Auditor to demonstrate that controls are effective. Not to improve them necessarily, but these are the ISC2 definitions, by the way. So the different teams and different work groups, they kind of come up with their own explanation of what they think an assessment or an audit is. Expect that to occur, but this is what ISC2 is kind of looking at. Your auditors could be internal or external. Most companies of a sufficient size have audit teams. And those audit teams, they go around and they verify that the organization's controls are implemented, and they write up reports and they provide them, and sometimes they're used by external auditors. External auditors, in at least publicly traded companies, you tend to see the concept of the big four: Ernst & Young, Deloitte, PricewaterhouseCoopers, and KPMG. They do audits. They usually have big technology consulting businesses. They do a lot of stuff. So the audit preparation phase. We don't have to spend too much time on this. You just want to have the right controls in place to understand what your target is, the risks, the control framework, and then you're doing that verification to see that all of the due care is being done on that platform or system. Audits and assessments, you will find concepts in the ISSA-PS related to consent. So everything is done with consent. whether it's white hat hacking or audits or assessment. Usually, it's particularly if it's not within the same organization, you'll see consent coming in written form with a whole bunch of disclaimers, right? So the audit phases, plan, collect data, do a bunch of meetings, offsite analysis, reporting, draft, and internal report. Generally, you just kind of want to memorize how some of these processes work, the phases. I don't know how specific you're going to get in terms of recollection of some of these things, but certainly like for the pen test process, there's a higher likelihood that you're going to see a question that relates to the process. We're going to talk about SOC reports, which are good. General thing is be prepared. Okay, here's a set of concepts that you want to memorize. And you want to understand and differentiate between all of these things. Note for SAS-70, I put a line through it. When we first started doing these boot camps, there wasn't a line through SAS-70. And part of the reason why SAS-70 is an old standard is because it was mostly focused around the idea of data centers. Nobody does data centers anymore. Well, some people
except the people who do.
Yeah, except the people who do. But nobody does, except those people. So SSAE 1618, ISSA-E 3402, those are what you see more often for public firms and the auditing of controls in them. So 16 is a statement of standards for attestation engagement, SSAE. That's what it stands for. Verifies controls and processes with a written statement at the end of control effectiveness. Very common sense. Now, SSAE 18, remember, SSAE 18 applies to service organizations, and you get a report out of it that could be either public, shared with your customers, or internal. So these are the SOC reports. And we have another slide here on SOC reports. So just remember, SSAE 18 SOC, service organization, reports that you can give publicly or to your customers. FISMA, you need to know about FISMA, the Federal Information Security Management Act. The federal government has done a whole lot more since FISMA. They did revise this in 2014. They've done a whole lot more. There are a bunch of executive orders that have come out, and those have changed the landscape entirely. But you probably won't see it on the 60 exam. At least I haven't found it yet. Have you seen anything, Mark, like CMM, any of that?
No, I haven't seen any of that.
It's too young. It hasn't fully sort of like worked itself out.
So the question that I have regarding to that is that given the fact that you're bringing it up and that it may or may not be on the test, what does that mean for practitioners, right? Or for,
it means practitioners still need to know about it,
right,
especially Biden's,
in a sentence or two, what's the main difference between 2002 and the 2014 FISMA that we might?
I looked at it. Maribel, you had a question too. You want to speak up?
Thank you. And I receive, I'm in cybersecurity, and I always receive questionnaires that request either, do you have the SSAE 18 versus the other ones? And I always have to look it up. Does that reference SOC 1 or SOC 2? So I think that this here will help me kind of pin it down a little bit. But do you have any other suggestions? Is there any other way that I can see it that I can automatically pick up and say, hey, that's a SOC 1 versus SOC 2?
Yeah. Let's wait for the next slide because it has it in very bold text. And I changed the color to this orangish color so that your eyeballs would be attached to it, right? Let me mention a few other things. Federal Risk Authorization Management Program, FedRAMP. Yes?
Very quickly, I want to go back to FISMA.
Yes.
And if you're a practitioner and you're working with the government, it's much more critical to your career that you understand this because they can't do it online.
Yeah. But it's the federal government kind of regulating itself, how it implements controls, what it does for information security. FedRAMP is something that you will see for those entities that are working with the federal government in the cloud. FedRAMP compliance is one of those things you have to do. So if any of you have heard of some of the bigger advisory firms like Coal-Fire or something like that, I have been through a process with them in the past where they work with you. They provide people who can guide a process to help build the program for, say, FedRAMP compliance. If you're running a cloud application as a service, you're providing something to the government, you need to make sure that you fulfill the government's requirements for information security controls and compliance program. It all needs to be well documented, and companies like Coal-Fire come along and help you with that. PCI, everybody should kind of know what PCI is. So it has changed a lot, and I don't think the SISP has revised since PCI 4 came out. But one of the things I posted in chat, for example, that PCI had this sort of nobody does it anymore 7-character limitation on passwords. That's the one that everybody knows about, right? It's now 12 because PCI 4 said, hey, 7 isn't enough. There are a bunch of terms in here too. So a QSA is a qualified service assessor, I believe. So in a QSA, internal QSAs? Okay. So QSA is a qualified security assessor. Those are the people that typically help you write your results of compliance to the PCI DSS set of controls. So your ROC is sort of a statement. Your SAQ is a statement that, these are all the controls. This is where we comply. Somebody's reviewed some evidence. A QSA would be involved as reviewing the evidence, working with you on your compensating controls, and basically getting to the end and signing it with you to say, hey, I kind of went through this process with them. They said it. I kind of verified some of it. Looks good.
The QSA is the person that has the function.
A person who works, I believe you have to be in a PCI, what do they call it, qualifying organization. If anybody has PCI expertise on the phone, I have still some certifications, but I'm not recalling all details precisely. So you can become a QSA when you have passed certain tests and worked your way up through the ladder of the assessment process, and you work for a qualifying organization. So if you are a firm that is licensed to do attested SAQs, audits, that kind of thing, you can have personnel within your company that take the tests and become QSAs and then work with individual companies when they're doing their attestations and then internal security assessors, their ISOs. That can be any member of an organization who is responsible for helping to implement the PCI compliance program. And they go and they take a class in Fort Lauderdale, and then they take a test, and then they get accreditation. And if you get the ISO accreditation, you also get PCI Professional. My ISO has lapsed. However, my PCI Professional is still good, I think, for one more year. And it's quite the process. You can renew, you have to go to the class in person, I believe, to get it initially. And then you can renew it every year, but they're very strict about the renewal. So they put you through a whole online training program. You have to take the test. You can renew it every year, but you pay like $1,400 or $1,800 every year to renew it. And then if you stop that process, then it just lapses within a year. So they're pretty rigorous about the QSA and internal security assessor process. Yes? Yeah, all right. I bring up all this stuff because you may see some of this on some parts of it on a test. I have seen peripheral questions around PCI show up on a test. SOC reports, service organization controls. So service organization is an organization providing a service to somebody else. When you do that, you need to kind of convince the other entity that they should trust you. This provides a mechanism by which you can do that. So typically, you won't see a SOC 1. You just won't. As a customer of a company that provides a service, you won't see a SOC 1. You would likely see a SOC 3 because you could go to their website and download it. If you are at some phase of engagement with that outside organization, you could request a SOC 2. And sometimes I've seen some vendors like GitHub actually has a compliance page. If you have a GitHub account, you go to that compliance section, they'll let you download the SOC 2 right there. So the SOC 2 is basically, it's a auditor statement that kind of says that you have the controls in place for availability, confidentiality, and integrity, and that you're addressing some level of privacy and availability controls. There are a lot of these kinds of formats. So like CSA, the Cloud Security Alliance, has their STAR program. And their STAR program, kind of like PCI, kind of a little bit like what AICP does with the SOC reports. You basically go through a process, implement a set of controls, somebody helps you verify them, and then you're able to get an accreditation that you can provide with your service. So like I mentioned, you can get a GitHub SOC 2. A GitHub is also STAR. And STAR has different levels. So there's like a point in time level, there's continuous. If you go all the way up to CSA STAR, I think it was 4 or 3, then it includes privacy and security controls. So some of these standards are now starting to include not just security, but then what are the controls you have in place for privacy. There are 2 types of SOC reports. You want to memorize this, know this clearly. Type 1 is a point in time. 1 point in time or 2 periods of time. Create something in your head to remember it. But 1 point in time, it's pretty clear. And the other one can only be 2. So I just kind of put some of these things in here. We don't have to spend a lot of time on the slides. Maybe this is good for review. But if you want to know, like, what are the criteria around security, it's going to include things like reviews of policies, security awareness, what's your training program, how you communicate with your end users, risk assessments, logical and physical access, how you control them. Your SOC 2 security section is going to focus on this kind of stuff. Your SOC 2 3 criteria around availability is going to look at things like backup and restore, environmental controls, disaster recovery, business continuity planning. We're clear about the difference between business continuity planning and backup and restore. There's an entanglement, but
So you cannot continue business if you lose everything.
well, so think of backup and restore as something that you do that allows you to basically recover data that's lost or that's modified or something like that. Whereas business continuity is more conceptual around the idea of getting the business back to a running condition, getting it back to
Steps after.
get you back to functioning. Not to where you were potentially, but at least functioning. Yes. Confidentiality, everybody likes this one. And then privacy stuff starts to overlap in it. Processing stuff. When you look at HIPAA and you look at some of the other standards, there's differentiation between processors of data because they can be third parties. So, and the people who own the information, the people who store the information. So you'll see these concepts come up. Processing is one of those things that you consider. Often in processing, there are a lot of third parties involved. And then privacy, also in there. All right, security controls testing. So here's where we get into some of those concepts that you really want to understand clearly. OASP has a list of scanning tools. It's a really nice list. It's mentioned in the ISSA-PS book. Doesn't mean you need to memorize the tools that are in it. But if you go to that list, the other one, there's the attack framework from MITRE we talked about earlier. You get a lot of stuff in there. There are other websites. I used to have a reference website and I had little blocks on the screen that sort of showed open source market share and influence and like commercial software. I haven't been able to find that link, but if anybody finds a really great one, let me know. The OS link, it's not too bad. There's some good stuff in there. So we have vulnerability assessment, which is not penetration testing, which is not dynamic application security testing. Penetration testing is different. We have log and event management. We have the concept of synthetic transactions. We have code review and testing. And we have a bunch of concepts around like what is negative testing, misuse case testing. There's a whole area of conversation around test coverage. A lot of companies aren't terribly sophisticated in how they do testing. Some of those that are instrument stuff such that when they test their applications, they can figure out how many of these code paths am I working and how many of these code paths are potentially dead. You'd be surprised how many applications, very large, very complex applications, a lot of the code within the code paths within it never actually get touched because maybe they're not related to something functional that somebody's improved. And a lot of the techniques that malware creators and hackers use is finding those code paths to see what happens. I've done this before. It's interesting work, and there are some interesting tools you can use to actually instrument your code so that when you do testing, it will give you precise numbers about how much of the code you hit. So, and then there's the concept around interface testing. So SCAP. Let's talk about SCAP because in the vulnerability assessment world, when we talk about anything related to patching and vulnerabilities of any kind, there is a standard set of terms, there's a standard methodology, and it's well defined within NIST, the Security Content Automation Protocol. You want to understand every single one of these concepts that are on here. I don't think you need to differentiate between the versions of SCAP, but it's on SCAP version 1.3 right now. And I did actually do a little research to try to figure out what did they improve, and I couldn't find anything that like I would stick a pin on and say, oh, wow, that's a big deal. So the key concepts. There is a content validation tool. There's a format for SCAP documents. So XCCDF, OVAL, OSIL, asset identification, and ARF, just know what those mean. The key terminology you really want to understand well is common configuration enumerations, platform enumerations, and the CVEs, common vulnerability and exposures. Does anybody want to venture a guess, like somebody describe one of these as opposed to another? Differentiate them. Anybody online want to give this a shot? So tell me, what is the difference between a common configuration enumeration and a common vulnerability and exposure, or CVE, within the SCAP language, except for an instruction?
I would guess that the common configuration scoring would be based off of infrastructure as code, and common vulnerability would be a package or a library that's attached to software.
Very, 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 yes. So the world has databases. If you create an Amazon S3 bucket or an Active Directory forest, or if you create something, somebody has defined a set of configurations, what's good, what's bad, and they've documented it somewhere. And tools, what Jeff was talking about, is infrastructure as code, is a way in which you take and define something that you want to create. Like AWS resources are often, in most organizations, created in code and deployed as resources from code in pipelines. So you have Git repos and you check it in, and some magic happens, and bam, an S3 bucket shows up on the other side. Now, if you didn't encrypt that S3 bucket, well, most people regard that as a common known misconfiguration of S3. You should encrypt your resources. So a common configuration enumeration database that includes details about those services would identify that, and they would have a ranking for it. They would say, this is kind of important, this is critical, or this is high, or this is low. So CC defines those configurations, and then common vulnerability and exposure, if you have software, and it's popular enough that people are keeping track, and a vulnerability is identified, it's pretty serious, it's disclosed, it's recorded in a database, and it's ranked. How bad is it? How easy is it to exploit? And that will determine whether, on a scale of I think it goes to 0, to 10, what it's going to be ranked. And then systems that you use and internal rules will determine, hey, what do I need to focus on? So PCI has, I think it's like 6 or higher. For a CVE, you're supposed to patch it within 30 days. Typically, you see the word patching involved with addressing CVEs. The scoring metric system, so CVSS and CCSS. For every vulnerability that you find, like if you find a patch, you're running Windows Update, and you see that there's a new update, and you click on it, you look in the description, you will probably see a CVE number, and you can search the web, and you can pull up in the scoring system, or you can pull up in the MITRE website exactly how that's scored. Some other vulnerability assessment concepts. Vulnerability assessment is the process for finding weaknesses. Just generally speaking, weaknesses, configuration, patches, whatever. A weakness in a system could involve features you need to add or patching or changes of configuration, right? Application vulnerability assessment is focused on those things that relate to application development. For web application development, OASP, you should really know what OASP is, and you should know the OASP top 10. It does change. And then I also saw in the SISP book, they also talk about, like, when it comes to interface testing, APIs, there is a API top 10 as well. I threw this one in, and I don't know if it's in the book. I didn't see it in the book. I didn't see it in the index. But KEV is a very popular thing these days. ISSA maintains a catalog of known exploited vulnerabilities. A vulnerability that nobody can exploit really isn't a big deal to you. If you have a system, it's off network, it's off everything, and it doesn't have anything critical, there's no critical asset that system delivers, or something like that, you really wouldn't care about it, even if it's a really big, it's a really glaring weakness. The same thing goes with application stuff. When you know that a vulnerability you have is exploitable, and you go to the catalog and you figure out how, that could change your calculus as to whether you should fix it, right? So systems now are starting to reference this KEV database. When vulnerabilities are found, they use it as a part of the scoring system when they're trying to prioritize the things that you should fix. Most of the systems we've seen, the modern systems, are not raw, just patch it. They are now more intelligent. They correlate data. It will tell you, okay, there's a vulnerability, and it's got this kind of ranking, and it's accessible from the internet. We're going to put this at the top of the list for you to fix and there's a known exploitable vulnerability. You put all those three together, hey, this is probably an issue for you. You better fix this now, right? They give you that kind of, yes.
So there is a model that's called ISSA-PS, Exposure Prioritization something system.
Yeah.
By first.org. So first.org is easy to remember.
First.org, F-I-R-S-T?
F-I-R-S-T, like once. Yeah.
All right.
And this prioritization scheme is described as ISSA-PS.
Yep.
And it's attempting to get at this. In very large organizations, you will find that you have A, lots of systems, and B, lots of vulnerabilities on those systems, and trying to figure out where you're supposed to go first. ISSA-PS incorporates KEV to help you prioritize and find those systems where it makes sense to go do this. It's probably not on the exam, but from a practitioner perspective, if you're in a large organization and you just are overwhelmed with the amount of crap that you've got to go try to fix, ISSA at first.org is one model that's based on this that helps you get there.
And the great thing about all these methodologies, so the list of vulnerabilities, those are maintained in catalogs. The lists of exploitable vulnerabilities, configuration enumerations. When you buy tools, so you buy this tool versus that tool, typically there may be a small differentiating factor. The company may have its own research arm, and they do something that, slightly value added. But for the most part, they're all giving you the same information. They're using common scoring systems. They're using common vulnerability databases. They're using a common ranking system, the CVSS ranking system, right? It establishes a lot of consistency in what you get. But like when I say some companies do a differentiating value, GitHub, for example, they are known to have their own research arm, and they have their own listed rankings. They do end up in common databases, but usually GitHub is releasing it first, and GitHub customers get that information first, something like that.
Something like that. And they'll, instead of calling it the CVSS, it's the GVSS, because it's the GitHub version of the common, GitHub vulnerability enumeration, right? So yeah, we all put our own little trademark on the term.
Yeah.
Go ahead.
So, two things that came to mind. One, I think the benefit of using models and structured matrices to score and assess and think about it is basically information overload, right? Really, the person that is receiving the information on whatever thing, you gotta know what's fire.
Yeah.
Right? Is it just smoke or is it fire?
Yeah.
Yeah.
And if it's smoke, where is the smoke coming from, right?
Yeah.
And so there was that, and then there was something else that I was thinking, the usage of the data of your customers, right? And I think thinking about large data sets that the companies are using, I've heard a lot of the vendors will pool the experiences, anonymize, and then you're getting that pool of collaboration from the customer set.
And that's where the last bullet comes in. So the whole point of the last bullet is you cannot expect anyone in an organization, an end user of a machine or system or application, to be able to know and fix, or to be able to do all of the right configurations. They need a developer of a system to make all the right configurations and code choices. You can't expect them to do it. That is the full realization of security assessment as it occurs in development pipelines. That's the full realization of vulnerability management within an organization. You will have to buy tools because you need something to discover. You need something to identify and match it up to the CVS scoring system and prioritize it. And then you need to have this value-added correlation to understand what is the higher level risk of this thing in any event, in any organization, given that you have systems and software and dependencies and all of this stuff. There are millions of combinations of configurations. There are millions of combinations of vulnerabilities. That ranking system, the prioritization system, is the only thing that saves you because you can't do all the work.
I want to quickly add to, sometimes when you're speaking to executive level, they just want to see the red, yellow, green too.
Yes.
And that helps.
So companies that have good governance methodology, senior executives will influence and review and understand the prioritization scheme, make sure that it's well set for the risk profile of that organization. Doesn't mean that it's absolute gold, that nobody can break it, because sometimes you got to make money, so you do what you have to do. But they want to see a dashboard. Show me the data. Are we meeting our objectives? And remember, that's not security, because you could have resolved all the vulnerabilities. You could have like the perfect system from the point of view of vulnerability ranking and classification systems. And you may have designed an application that is just fundamentally, functionally insecure, and you get busted. So this isn't necessarily security, but so we mentioned in the first week, there was a book by Tim Raines about cybersecurity, and like the five horsemen of every breach. It's security, it's misconfigurations, leaked credentials, phishing, insiders, and vulnerabilities. I didn't repeat one, did I? No. Okay. Yeah. So generally speaking, those five, they will be involved with every breach that occurs. Yes. Well, insiders come in two flavors: malicious and And then, you know, if any of you have sort of read the psychology of like things, right? So if you've read like Don Norman, what is it? Design of Everyday Things. So one of the things is, so you've heard of the Norman door? Anybody heard of a Norman door? We have this door right here for the conference room. If it's closed and it only opens one way, and somebody walks, Norman door.
Norman?
A Norman door. This is from Don Norman. It's a fantastic book. You should read it because once you read it, you realize like, it's not their fault, it's my fault. So the idea of a Norman door is somebody designs this glass door. It's beautiful. It only opens one way. And half the time, people are walking into that door and slamming into the glass because they don't know which way the door opens.
And it only opens one way.
It only opens one way, right? So the Norman door is a system that makes you make a mistake. When people don't fix their vulnerabilities or they get breached, generally speaking, if you're believing that it is your responsibility to keep them safe, it's your fault. It's not theirs. If they open the phishing attachment, you should have marked it that it was external, that it wasn't from inside the company. You knew, right?
I'm mostly referring to sending a spreadsheet of SSNs unprotected via email, following policy.
Yes. There's that. There's that. But who reads policies? Who reads procedures? Kyle and I had this conversation just yesterday. There are too many.
So you think it should be captured via tech and not be able to be sent out?
Yes.
Yeah.
If you really care about it,
Say it
you
again.
will go at it. She was saying, do I think that you really need to catch it if they do it and let them know that they're not supposed to do it? Yes. So that's where DLP comes in. DLP vendors will come in the room and they'll say, look, people do what they do. Sometimes they take the list of patients in the medical facility and they email it to their home computer because they need to work on it when they go home.
Yeah, and I'm already wondering why those weren't somehow obfuscated or, you know, how did they get this list of social security numbers?
So if you don't encrypt their laptops and they lose it, you knew they were going to lose it. Everybody loses a laptop at least once in their life. And if your critical stuff is known to be on that laptop, encrypt it and make sure that that laptop has the controls so somebody can take it, a bad guy can have it, and nothing can come of it, right? It's always your fault. That's the key point
Well,
here.
the thing is, it is and it isn't, right? So
Yeah.
I'll give you an example. I did some test remediation for bias for the College Board. They have older faculty, right, that are seasoned professionals doing these critiques. So their first security process was, we're going to have you sign a non-disclosure agreement. You have to agree that you can only review these tests in this type of environment.
Yeah.
Mind you, they're shipping it to people all over the country.
That's a good administrative control because you explicitly and you ask them to sign it.
Agreed.
When
Hold on.
people have to
I'm
sign
going to
it.
get to the problem of it, though.
Okay.
So the first time it was paper.
Yeah.
We migrated over to a technical solution that then made the feedback process kind of like switching through Excel spreadsheets and documents that you couldn't do screen capture.
Yeah.
So they tried to do a control to mitigate people from stealing the information. People that receive these files on this hardened digital form
Yeah.
may or may not have had the technical aptitude to be the hackers, but they all carry cell phones with them. And if they really wanted to, could just take a picture of that screen and send it to themselves and we would never know.
Yeah.
I think sometimes the security processes do not always take into account who the users of that are going to be. Then that requires more time,
Yeah.
more learning.
So this is where risk methodologies come into play. Your risk methodologies try to help inform you about what kind of user are we working with, right? If you're in a call center, you have high turnover rate with your staff, you're dealing with payment information, you're dealing with private information, you're dealing with sensitive information, you would design your security control matrix in a completely different way than if you were working with a group of people who had explicitly signed something, had a high level of trust because of some background that they have. So somebody asked me, what is the name of the book that talks about the 5 things that will be involved in every breach? And that is Cybersecurity Threats, Malware Trends, and Tim, is more than open. The title of this book was made by his publisher because it would capture the right audience, but it starts with cybersecurity threats, malware trends, and it's Tim Raines.
Yeah.
And everything in that book is really cool because I was the Windows Update product manager at Microsoft. And so he's basically speaking the language. When he goes through the data, you can actually see where a lot of his data stops because Microsoft stopped releasing it. When we were doing the security intelligence report and Microsoft's methodologies for sort of managing risk in the Windows ecosystem, you see all of that, the methodologies on display in his book. It's pretty cool.
What's the book called? What's the book?
Cybersecurity Threats, Malware Trends, and Strategies from Tim Raines. And he also talks about new things that aren't in there, like attack kill chain and stuff like that.
Was that what he presented on at ISSA?
Yes.
Okay.
Yeah.
Do you know if that recording is available?
I don't believe so. That was the book that he gave away too. Yeah.
Because I think he said he was going to reserve the right to decide whether yes or no. So I'm just wondering if anybody in the audience that is an ISSA member would like to see the recording, maybe Mark or...
I don't think that he wanted it recorded.
Agreed. And
Yeah.
then he said he was okay with recording it. And
We can move on from it because I don't think that would be something that they would do. So too much of a complicated process, but too senior of a guy to really ping him every single time. You can read his book though, and his book is awesome and it's probably in Audible format as well. So vulnerability management workflows, the basics of the basics: detect, validate, remediate. And then remember, it is for everything that we talk about, these are all circular processes. So detection, validation, remediation, and then validation again, and detecting again, right? It keeps going around in a circle. All right, know these concepts. We talked about them in domain 3, some of them. So TCP SYN scanning. Also, SYN is sometimes used TCP. So the TCP IP protocol has a 3-way handshake. So it's SYN, SYN-ACK, ACK. You can send something, you get an acknowledgement back, yeah, I'm here. Send me your data. So you acknowledge it, send it, right? So people play with this protocol. You can send things out of order. You can just send the SYNs. It's easy to send the SYNs, and you can do things. So you have, in the world of sort of attacking things like denial of service, you have volumetric or protocol-based attacks. So the idea is that one kind of attack, volumetric, is about throwing as much as you can at a resource so that it can't respond to something else. And then the cloud vendors come along and they say, hey, we'll allow you to scale to infinity. So they'll throw all this stuff at you, and then we'll scale up and your stuff will still work. Really great, but now that's expensive. So other vendors come along and they say, hey, we'll detect the volumetric attack, and then we'll take and we'll just like isolate those people, unplug them from your service so that you don't have to pay all that money. And then there's the protocol attack. So the protocol-based attacks are attacking things like HTTP connection. They're attacking things that, so if you're connecting to a DNS server or you're connecting to a web server, there are different ways in which you could play that system. And you play that system so that it can't respond to anybody else. I've seen people do this accidentally and maliciously. In one case, as the Windows Update product manager, we had a very large hardware manufacturer, PC manufacturer, come to us. They had quality reporting, so like, you use their software, usage reporting stuff. They had a piece of software, and it would send data back to their systems. And it just so happens that the pool that they used was the same pool that they used for their global website. So you could buy computers. And the way that they had updated that software and then they pushed it out, it would connect to the web servers in such a way that it would soak up connections. And so they couldn't scale up enough servers because their servers could only handle so many HTTP connections at a time. And they were denial of service attacking themselves right before Christmas. And so Microsoft had some tools, so we can't deliver updates for another company. That's against the rules, because when you sign the Windows terms, that's not allowed. But we can shim. In Windows, software runs, you get a new version of Windows, your old version runs. Well, that's magical. It's not entirely magic. There are teams of people at Microsoft that work with a system in Microsoft to shim the software so that it works. It basically bridges something. So if Microsoft got rid of a particular system call and replaced it with something else, this would create a bridging mechanism so that system call would still work, the application wouldn't crash, and your application would be fine because they bridged it. And so they do all this research, they test all the popular applications, they make sure they work, and that's how you see software work in Windows version after version, even while Microsoft's changing everything. So in this case, we shimmed that software to make it more compatible with that global top 3 computer manufacturers' website so that they wouldn't be down over Christmas. And this is not the same as a Christmas attack, an Xmas attack. So TCP, you will find information about the Ethernet protocol, TCP/IP, in the book. Use Wikipedia as well. Wikipedia has really nice information for just sort of like quickly digesting how things work. One of the things you'll find in TCP/IP is that there are flags. And you can, now, typically designed system running the way it's supposed to, it uses the flags appropriately. But if you're a malicious actor, you can play with the flags and see that if you can trick some system into misbehaving because of it, that's an Xmas attack. Turn all the flags on and mess with the TCP/IP protocol on the system that's receiving the connections. Know the difference between UDP and TCP. UDP is connectionless. That's the key thing. There's no handshake. I send something in UDP, I'm not expecting a response. It just goes. With TCP, I'm expecting to say, hey, you there? Yeah, I'm here. Send me the stuff. Okay, here. I acknowledge. Here's the stuff. Oh. All right, network scanning stuff. There's network vulnerability scanning. There's authenticated scanning. One of the things I wanted to differentiate here is that in the world of vulnerability assessment, there are really 2 kinds. There's authenticated and unauthenticated scanning. Unauthenticated scanning is spinning through IP addresses and then spinning through ports. So if you want to do it the long way, you can spin through all 65,534 ports and see if anything responds. If you want to do it the short way, there are about 1,024 ports that a typical system and most of your protocols work on. So if you connect to a DNS server, you're going to connect to it with port 53. If you connect to a web server unencrypted, it's going to be port 80, typically. Doesn't have to be. Things can run on any port they want to, but typically you would expect it to be 80 and then 443 for TLS. So the port thing is really important. You should find, again, Wikipedia is good at this. Go and search for that common TCP/IP ports and memorize the link between protocols and their ports. Yes?
How many are they expecting us to know? Because, I mean, there are hundreds out there, 20 of which are maybe commonly used.
The ones that matter.
How do you know the ones that matter?
SSH, FTP, TLS, non-TLS, I don't know, RDP, SQL Server, Oracle Server. You'll find a list, you know, and once you like hit it a number of times, you'll just actually start remembering it. So, you know, and it doesn't mean, again, that it's always on that port. There's nothing that locks it there. The daemon, or the service that runs on a machine, could be started to listen on a different port. And you can connect to things on that different port. So, and this is one of the problems of the modern world. So most corporate firewalls will allow 80 and 443 through. And they'll block things like 22 and 21, because 22 is SSH and RDP 3389. They'll block some of these ports. So at least if you're going in or through boundaries, or even on your machine, now a lot of this is done right on your machine, but even if you're going in between boundaries in the organization, they'll prevent you from connecting to RDP and, say, a server subnet from a client subnet. This is all legacy speak. In the modern world, nobody's on the network. You're all like over, like given very specific access to like services. But a lot of the world still works this way, and the CISP world probably still thinks this way. Boundary firewalls prevent connections on ports. Typical stuff might include somebody wants to give somebody the ability to connect to something and get around that rule. You could start up SSH on port 443, and if you knew how to connect to it on 443 from this other place, you could go through the boundary firewall because it thinks that you're talking about TLS. Yeah. Authenticated scanning is when you typically either connect to the system and remotely interrogate it, what is installed on it, what are all the patch versions of all the stuff. That's the authenticated server patching concept. Or there's an agent running on it, and that agent runs on some schedule, and it generates a list, and it sends it to a server, which then puts it in one centralized place. For a Windows machine, Windows Update is doing that for you. It is scanning the system, identifying, checking the Microsoft database. Hey, which of these Windows or Microsoft updates need to patch, which drivers, right? It's doing all of that work. When you move it into a corporate setting, there's a service that used to be called Windows Server Update Services, WiCys, or you have System Center Configuration Manager. There are a number of tools they have for enterprise context. WiCys was a free one. System Center was expensive. And so what they would do is they would aggregate that data about each individual system to a common platform where you could then make decisions about which updates to approve and how to push them out and force them out, right? So like you get that prompt in a company and it says, your system will be patched tonight. They're probably using something like System Center. Yum APT, those are it depends on the version of Linux that you're running for Linux, but it's either Yum or APT to update and install software. Yeah.
Is there any reason why it's specifically those package managers compared to like something else? Like Pac-Man or?
There are a lot of package managers.
Yeah, I know.
Yeah.
So why specifically Yum and APT?
I'm just mentioning stuff.
Oh, I was thinking it would only show those within the test.
Within the test, I don't know if you'll see it, but conceptually you want to be aware of it.
Okay.
Mark, you specifically ever remember them mentioning Yum or APT as package managers for Linux operating systems?
I haven't seen it in any of the current materials that I've read, like the last time I took the test was 2002. So
Yeah.
APT were not a thing that they didn't exist. So, yeah, no, the answer is I don't think you're going to get to that level of detail.
I mention some of these things because it helps people connect dots. Right.
Okay, so also the APT, which is the Apache package manager, what is APT? Something package manager. But yeah, apps, get apps, whatever. APT is overloaded because it's also advanced persistent threat, which is probably in the
Yeah, that probably is in the book. Yeah.
important definition to think of.
And just to review, anybody want to define an advanced persistent threat? Okay, so think of an advanced persistent threat as somebody who has sort of organizationally funded and skilled resources. Their goal is to get into your organization and stay. They show up as a friendly actor. So they will use unfriendly techniques. They'll exploit a system, they'll exploit a platform or whatever, and then they will install sort of their command and control software, their backdoors, their whatever you want to call it, their software around the organization such that they're now inside. You could find and replace a system, that's okay. They have another 1,000 locations in which they can operate. It's no big deal. And then usually they're operating out of some office complex and they have sort of a government allocated budget. And so nation state actors, right, are people who are typically working in an organization to do this. You also have extortion, financial stuff is what drives. I saw the Verizon breach report, Jake's podcast. He and Kip are going through the Verizon breach report right now. I don't know if they've produced their second episode of this, but the first episode of this, they were talking about this, and financial stuff is still like at the top of the list. Jake, correct me if I'm wrong. I was listening in the car. Okay.
But-
Sometimes people will hear their name and then they're like, whoa, I should be paying attention. What was the question?
I think the important thing about advanced persistent threat is that it is like you are an organization and you might see indications that people are attacking you. These guys are not script kiddies. If they don't succeed today, they will try again tomorrow, and they will try again for years. So this is the thing that, like, if you were a defense contractor, the Chinese and the North Koreans are going to try for years to get into your system. If you're a bank, the bad guys that want to steal SWIFT codes, they're going to try for years to get into your, if they don't succeed today, they're going to keep trying. So
this is where standardized systems come to help you again. Indicators of compromise. Which organization is it that produces a list of indicators of compromise? InfraGard sends them out, but I don't forget who actually creates them. So an IOC would be a standardized identification of a thing that you should look for that indicates potential compromise. It's an indicator of compromise, IOC. There's a database of them. I think there's like one organization that kind of drives the reporting on this. Some of your companies like Mandiant, they probably contribute to and have all this built into their systems. So a proper system like this will have like potentially 3 different methods. So they have signature method. They will identify a compromise based on a traffic flow they're inspecting that matches a signature to something that's known, an indicator of compromise. If they connect on this port and there's this kind of data load and it responds to this IP address, ooh, that's command and control for a particular actor, right? Indicator of compromise. The second level of this is heuristic, which is sort of like, I have a rule, I can kind of figure it out. It's coming from Russia, it's got to be bad. That's the second kind of method.
What was that?
Heuristic.
HEU.
I think a better way is it's an algorithmic approach looking at patterns, right?
Agree, but the word is important.
Heuristic.
Yeah, HEU.
Oh, man. It's a spelling competition. If you Google it and you even get it wrong in Google, they'll still give you the right answer. HEU are ISSA-PS. Heuristic. Yeah. What was the third one?
I don't know, but you're going to tell us.
go back again. I lost the thread.
And now there's, these are the, and this is not on the test, by the way. So you have signature-based heuristics. There's a third one, behavioral, I believe is the third one. And then I know the fourth one now is behavioral is being amplified in its effectiveness with AI.
Yeah.
So AI has this remarkable ability to pick up patterns and to differentiate patterns. And if you train it on a model that says, hey, let me know about these patterns that are probably bad, and you train that model, you'll probably make a lot of money. So don't ignore AI, learn about AI. CSA has a whole new set of subgroups that are just ramping up right now on AI and AI security. You can join them as the public. You can observe, you can get draft documentations, you can be a part of the working group, give feedback. Yes?
And I was going to say that with items 2 and 3,
Yes.
I would caution security technologists and professionals to consider the calculus that is complex in our brains
Yeah.
that allows us to receive information, put it through our internal invisible bias chamber
Yep.
of knowledge, experiences, red flags, right?
Yep.
And think about the intersectional pieces, right?
Yeah.
Because a lot of the literature that I have seen, particularly in enterprise risk environments
Yep.
that focus on like retail, will give telltale signs of behavioral components that could be
So,
Problematic.
Are you talking
Yeah.
about cultural things?
so what Dr. H is highlighting is a very common problem, which is that you may have a thing that you do that has always seemed okay, and everybody has always done it that way, and it's horrible.
And
But
also,
it was okay there. I mean, everybody thought it was okay, but that time that you get breached, so like the planes, before 9/11, you could break into the cockpit. Everybody knew you could. It was like, well, who's going to do that? The plane crashes, you're going to die. This is a bad idea. Nobody's going to do that. And they did. And they're like, oh, well, I guess. Probably better fix that. So most of what you find gets fixed in cybersecurity. Most of what you find gets funded in cybersecurity comes from a breach. There's no action. The behaviors of the people are sort of aligned to like, yeah, it's all good. You know, like we've never had a problem with that before. And then they do, and then it's like, oh wow, I hadn't even thought of that. Yes.
Sometimes things are identified as a potential problem in advance of them occurring, but it's determined that the risk of it is so low that they don't want to pay the cost to mitigate or.
So as a cybersecurity professional, one of the things you want to do is two things you want to do. One is be able to see those things that it's just everybody's oblivious to, that they thought, no big deal, we've done that forever, right? And then two is, how do you raise the awareness of decision makers? It needs to come from the top down if it requires funding. How do you raise the awareness of decision makers to something before the breach happens? That proactive element is very hard to do, because then you get into the world of like, if you use scare tactics, some people don't like that. Most of us don't like that. If you lose your credibility because of a scare tactic, then everything you said doesn't matter anymore. So it's a really complicated world. One of the best things that I like to do with this is when you see that thing that's hurting somebody else and it makes the news, you share it with your people who are doing the same thing. You're like, oh man, we do that, look at that. And they're like, and then people will go, oh wow, you know, especially if there's like a big dollar or somebody got fired or something, like, yeah, we should pay attention to that.
but I think, you know, the other part with the behavioral is the fact that there could be signs that are behavioral.
Yeah.
That are mimicking other things. So for instance, somebody that has OCD might present things that for somebody with a different flavor of it, right, might clash and might impact that behavioral in context, right?
It's like the Elon Musk effect, right? Yeah.
Or the, what's his face, right? Like Snowden.
Yes.
Right.
Productively disruptive or illegally disruptive. Yeah.
Or things that happen. So for instance, in 2019, when Citibank was breached, right? And I'm going to bring in some layers of stuff that we normally don't talk about in this space, but the person that came out in the headlines of the Seattle Times for the Citibank breach was a person that was seen as volatile. Their handle was chaotic something.
Yeah. This happens all the time.
And
so let's
gender component.
I only have so much time. So I just kind of like, so Nmap. Nmap is explicitly mentioned in the book. Nmap is a tool that you can install. It is free and it is awesome. There's also, skipping my brain, what is the packet capture tool? Wireshark.
Wireshark, yes.
Wireshark is another tool that is really awesome. So Nmap, you can scan ranges of IP addresses, you can scan all of the ports, you can scan subsets of the ports, you can control all this in very nice ways. And then it also has some volumetric, or it has some protocol-based intelligence as well, but it's mostly a discovery tool. So think of it that way.
So you probably won't get a test on like what are the parameters to Nmap, but they'll probably ask you in what context would you use Nmap?
Yes.
So understanding that what it's doing is, you know, looking for open ports on system,
Yes.
understanding that Wireshark is doing packet capture for later analysis, you know, and they're not going to quiz you on like how do you take apart it.
You should know the difference between the port states, open, closed, or filtered. And remember, the key thing with filtered is not necessarily that it's a firewall in the way, because most systems now have host firewall. It's that it could be a firewall. They're unsure. Yes.
Couldn't it potentially also be a web filter or some other?
Those are forms of firewalls. They operate at different layers, right?
Right.
So firewall typically operates at what, layer 4? Connection-based firewall, layer 4. Whereas a web filter, which is essentially
Protocol.
looking at things that are being done in the protocol, it's operating usually at layer 7. So WAF, Web Application Firewall, is a layer 7 device. It's inspecting the actual transaction of HTTP, of that protocol's information, and that something bad isn't happening there. Web vulnerability assessment. So web vulnerability assessment is when you scan a web application for vulnerabilities. This is where OS comes in. Your vulnerabilities can be at 2 different layers. So if you scan a web application's headers, you get its service headers. So the web application software, let's say it's Apache, is running on 8443. You can interrogate it to get its service headers. It will tell you, unless blocked, I'm this version of Apache, I've got these things installed, this is who I am. So one of the controls that most companies implement is they block the service headers from being presented. PHP, Apache, they're very useful for diagnostic kind of use, but then when an attacker can get access to it, they can find out, oh, that's Apache, it's 5 versions down, these are the security vulnerabilities I can potentially exploit. Let me go ahead and work through that list. And if you have Metasploit and some of the attacking tools, you can just go ahead and just attack it, find out, and it will like attack specifically on the version, or it'll Hail Mary, which is essentially, I'm hitting a web server, I know I can do all these things, let me try all of them. So that's typically like a vulnerability patch management kind of issue. Then web vulnerability assessment is more like an application issue. So when you look at OS, you have things like injection, scripts for SQL. The idea there is that if you don't properly sanitize the inputs that can be provided to your web application, you could potentially tell the web server, go ahead, or the backend code, to go ahead and query the database in ways that you didn't decide. And I've seen so many applications where the permissions to access the database, let's say it's SQL, are SA. What is the SA logon? The SA logon allows you to delete the database with a SQL query, delete tables, erase them, do anything you want, right? So SQL injection is a bad idea. People can get information they shouldn't have. They can query your tables and explore around. They can also just knock your application offline. So a few years ago, I had a friend who ran a website for a company, and somebody was repeatedly deleting their database. And they couldn't figure out why, how. They didn't have the tools in place to stop it. It's a naked web server on the internet. And yeah, he eventually figured it out. But for a while there, they would restore the database, they'd get the system back up and running, and while they were researching it, 3 or 4 days later, boom, hit them again. They were just basically, you know, reminding them, like, I'm still here, you still haven't fixed it, and until you do, I'm going to continue doing this. Yeah.
XKCD, where the parents have named their child something like Robert Drop Table Students.
Little body tables.
Yes.
Little body tables. Yeah. Web vulnerability stuff can be it can be very interesting. There's some tools. Burp Suite is mentioned in the guide. Burp Suite is free. You can install it. You can scan a website. You don't have to ask Amazon and Azure for permission anymore to scan a website. Obviously, you could run afoul of certain laws. I have attorneys here who could potentially respond if I said something that is a bad idea. But Burp Suite is a tool that many organizations or many professionals will use to learn how to explore applications that are developed, identify if they're injectable, identify common sort of vulnerabilities within them. Another one is a tool from OAS called ZenMap. So if you have a Mac, you can install ZenMap like with Brew. Brew is a really great package manager, by the way. So is Chocolatey for Windows. But you can install ZenMap. You specify the HTTP target that you want to scan. It will tell you all kinds of stuff about it. Is it injectable? What kind of security headers are they presented? It'll tell you all about about that application and some of its vulnerabilities. Usually a pen tester will use like 4 or 5 different tools in order to find all the various vulnerabilities, because some tools do some things better and some don't. Yes?
You mentioned already, legal implications of this, but I'm curious because several years ago it was severely frowned upon, and I believe there might have been some talk of legal action about simply scanning sites where you do not have permission to do that. Is that something that you think has changed in recent years? Using tools like Burp Suite and all of that. I mean, it's a little bit of a slippery slope if you don't do
somebody
anything.
has a public website, you could scan it with something like Burp Suite. You're not legally liable, right? But if you find something and you access information, or you do something that's not, you were not granted rights to do under the terms of use, then you can.
Yeah, it would depend on what their privacy policy in terms of use say, but it's definitely, regardless of what those say, illegal probably at a state and federal level outside.
Yep. I can tell you, if you're running a web application, there are a number of organizations around the world that spend their time finding your vulnerabilities, whether you like it or not. They don't ask your permission, and you can't tell them no. There's one in Germany. It's like a foundation or something like that, and sometimes they'll notify you. Like,
I get that you can't stop people necessarily. I'm more worried about a company scapegoating someone for doing it, which is, and I know it's a very gray
They
area.
likely wouldn't just because of the legal ramifications on that, the backlash on that from a PR perspective, but from a legal perspective, if anything is breached,
yeah.
they want to keep, they want to take care of that.
Okay, thank you.
You're welcome.
It always changes, and it's so interesting.
It is.
What you can and can't do, and
Yeah.
so it changes.
Here's what I would say. If you're in an organization, if you're in somebody else's organization, if it's not yours, if you have the capacity, if there's a reason why you're doing it that is in somebody's benefit, ensure that they either invited you to do it or get their permission to do it, and that is the best way to be safe on this. There are companies that run bug bounty programs, and they invite you to find vulnerabilities, and that's okay. As long as you tell them, they will pay you, and you're cool. You sign up for their program, they'll even transfer it via ACH into the bug bounty fees into your, or rewards into your account. Yes, ma'am.
I would also say if you're going to do this, make sure your ISP knows about it, because depending on who they are,
Yeah.
they may see you doing that and think you're a botnet, and that's it for your internet access.
So, well, yes, there's some of that. As a Comcast customer, I would say that I have not seen that kind of reactiveness, because tools require vendor agreements, require cost. And most companies won't pay the cost. But you also find when companies are going to replace their firewalls these days, they're getting layer 7 firewalls. They do all kinds of stuff. And they have nice algorithms. They have nice tooling built into them. And if you want to pay for the various subscription fees, license, all the stuff, you get the full kit and caboodle, it's pretty good. They may be able to catch anybody who's just randomly wandering on your site to go to sort of give it a spin. About 5 or 50, whatever that metric is that they have set, when they figured out you're playing, they'll just cut you off. There's Amazon had for websites, for WAF, a security automation framework. And they built it, and it was an event-based function. So somebody's hitting your website, when it hits those triggers, it would automatically just blacklist you for a period of time. And it's a stack, a CloudFormation stack that you can deploy into your account, next, next, next. They tell you how it works. I think they tried to kill it at some point, and then customers came back and no. So there was this, hey, it's dead, and then all of a sudden now we've got version 2. Most of your WAFs now have it built in. So Microsoft's WAF v2 in Azure, and Amazon WAF has botnet. You have all kinds of controls. If you don't want to take connections from regions, you have abilities to manage that. If you want to take connections from Tor or from other known malicious bad sites, you just want to block them entirely, you could just check boxes. But let's move. What's that? Tor is a Tor exit node is known as potentially a place where not your typical end user is coming from. At a minimum, you would have to install the Tor browser, and you'd have to be working at it from that point of view. Generally speaking, if you're coming from Tor, a lot of companies see you as probably undesirable, and they'll just go ahead and block you off the bat. And people keep databases. One of the things I wanted to mention here is this whole thing about TLS. So understand TLS, ciphers. Ciphers are busted. You heard Gene talk about triple des being busted. It's been busted a long time ago. SHA-1, it's busted. Like the ability to like take that cipher, get back to the original, very easy. So when you have web applications, you tend to do, particularly if you're doing like PCI, they have explicit requirements about what you can allow and what you have to disable. So your web application firewalls, your application servers, they're designed to ignore TLS 1.1, it's what TLS 2, and then typically now you're accepting AES 128 and 256, and you can ignore just about everything else because most of the browsers are already supporting those protocols and their security controls. Because everybody's on Chrome, everybody's on Firefox, everybody's on IE. There's a Wikipedia article that will show you the matrix of ciphers and TLS suites that are supported by major browsers when they phase out. You can look at that, kind of inform it. But if you're running a website, I would say disable everything but TLS 1.2 and higher, and AES 128 and 256, and your signing cipher SHA-256 or 384, you're good. Wireless scanning. We talked about driving, war driving. So there's a war driving concept with wireless scanning. War driving is kind of like the idea, like if you had a system, you could drive around and you get all the access point broadcasts, you just started recording that, and you recorded information about those access points, and you created a database and you put it online. People will subscribe to it, and they will go and potentially, try to do stuff with it. So wireless scanning could involve doing things to make stations inaccessible and unresponsive. It could be trying to get into them so it can send traffic, and all kinds of stuff. So just, yes.
You'll find this in like retail locations and so forth, where you're looking for wireless access points that aren't yours, but they're in your physical location.
Yeah.
And so that's a security control. Somebody else is providing Wi-Fi access or attempting to spoof Wi-Fi access, those sorts of things. So yeah, this is control for this.
So if you have a secure area in a PCI regulated card holder data processing environment, card holder data is, a person's PAN, credit card number, and, the expiration date, CVV. Right. There's a basic set of information about what card holder data is. It's not everything, just a subset of that. If you are processing that in a facility, there's a quarterly process in PCI that you have to find any wireless access points around you. And the primary means is you don't want people to be able to connect to wireless access points from their work machines where they're processing the card holder data, or from their devices, and using that to exfiltrate data out of that protected environment to put it into some place where they don't have the controls to prevent them from using it inappropriately.
Right.
So that exfiltration concept is very important. That's when you take something that's inside some protected space and you figure out how to get it outside of that space. You've exfiltrated it.
Yeah.
And there's some great tools for doing wireless scanning, by the way. They're like these little $29 RTL, I forget the name of it. If anybody really cares about it, you can send me. Very powerful wireless access point. You can plug in USB and has all the channels. So there's some channels that aren't used in the US or US devices, used in other parts of the world. This one is like really cool. And then you put some software behind it, and you can do all kinds of you can find all kinds of stuff and have all kinds of fun. Yeah, from great distances away too, like not your typical wireless distance.
I don't know if there'll be a question on antennas, but yes. So using parametrically shaped antennas to be able to get if I'm line of sight over there on the top of that building, I could use a specially designed antenna to pick up the Wi-Fi that's in this building, although typically you don't have that kind of range. So there were some questions in the days around this, but it's still maybe just, using long-range antennas to pick up on wireless stuff that you don't think people are going to be able to do. And you can get ranges of up to like 5 miles on Wi-Fi done right. Yes.
So remember, memorize those concepts: WEP, WPA,
Yeah.
EAP, EAP 802.11.
Yeah.
There's one that has 4 letters after it too. That's the one that's involved with authentication.
Skim something, blah, blah, blah. Yeah.
That skim's different.
Yeah.
You mentioned the amplification. Is there anything on the test that talks about controlling, right? So like, I'll give an example.
Conceptually, no, not as much.
Okay.
Yeah, not as much. But conceptually know what the protocols are, what's insecure, what's secure, and know the difference between encrypted and unencrypted wireless traffic, right? So conceptually understand the very basics of this. But because this is a set of material that is not updated every month, like things are broken every month. So if you get too specific, your stuff is out of date before you even got it out the door, right? So they would have to stop printing books. It would have to be like a live compendium of information, and the test would be a live. This is actually the next step. ISSA-PS is currently a point-in-time test, right? Of knowledge, of point-in-time data. The future certification will be an assessment of your ability to stay continuously updated in your knowledge of security information. And that's going to be the harder certification to get. Okay, so we talked about configuration scanning a lot before. File content scanning. A lot of your DLP providers do this. I've worked with organizations that use like WiCys, and there are some other tools as well. Identity Finder was one that was open source. I think it was like Carnegie Mellon. That was something dog. And then it turned into a commercial product called Identity Finder. So the key thing is that there are algorithms that you can use to figure out, is this potentially card data? Is it PAN? Is this a social security number? Is this an address? So using those algorithms, which are pretty efficient, systems now will take a source of data. So like say you're using WiCys and you configure it to look for this stuff. It may target your S3 buckets and look at the unencrypted data that it has access to in that bucket and find out if there's something in there that has cardholder data. If it finds a list of credit cards, it will tell you. If you enable the DLP software for Microsoft Office, so you pay for Office 365 E5 plus security, they will give you the option to turn on this thing that will prevent your Office 365 email or OneDrive from taking data that has cardholder data, social security, or personal information. And I've tested it out. It's really cool. You enable the features, lock it, you send that email with the stuff in it, and you get an immediate response to the administrative address that says somebody's trying to send this out, or they put it in a bucket. We talked about some tools like Nessus. People don't talk about Nessus as much anymore. There's a lot of better stuff out there. Penetration testing. Get a lot of questions about what is penetration testing versus what is web vulnerability assessment or web security assessment or whatever. Intent. A penetration test is using those vulnerabilities that web vulnerability scanning found. A pen test intent is to get something or do something that you weren't supposed to be able to do. That's the intent. You could have a whole bunch of vulnerabilities in your app. Nobody can exploit it. No big deal. You could have no vulnerabilities in your app, and somebody can still exploit it. So pen testing is a distinctly separate activity from vulnerability assessment. Pen testing is usually a human actor. In the future, it will be some AI bot. But it's usually a human actor that is trying to figure out, both from vulnerability assessment, from their own skill set, from training on a set of tactics and tools, tools, tactics, procedures that they learn.
TTF, yeah.
TTPs.
TTP.
They are using their skill as a person to break your app. So a good pen tester is very, very valuable resource. There are classes, and they teach you the skills. They teach you what you need to learn and what you need to stay up on, and they give you access to tools. And between you and tools, your idea is to break the app, get something you weren't supposed to get, do something you weren't supposed to do. So that's penetration testing.
Demonstrate that the vulnerabilities seen actually are an issue.
Yes.
In spades, yeah.
We have seen systems, environments that are fine in the vulnerability assessment, and the pen tester eats the system in a very short period of time. We had one such thing. It was related, I believe, to SMB unsigned packets. So SMB is server message block. Windows uses it with file sharing. It has different ways in which to encrypt some of the payload that go in it. So you have to sign your SMB traffic. Otherwise, there's a hash in there, and you can beat the hash, like with the right tools. And then you can use that and the hashes to gain access to systems, and use that access to systems to find other hashes of more valuable logons, potentially. Like if a domain admin is logged into a system, you get some of that stuff that you need, that seed material, you can figure out how to log in as the domain admin, and at that point, you're in the front door, you can operate like an advanced persistent threat, you can give yourself accounts, you can give yourself access to things, you can install malware wherever you want. And a pen tester did that in an environment that otherwise was clean in every other regard. And they beat us on that, and it was very embarrassing. And the guy was giddy too. That was the thing that really pissed me off. He was so smug about his finding. But there was a thing. So he got the domain admin password. We had another control, which was basically that everything in the space had to have MFA on it. So even if you had the domain password, you couldn't use it to get into a system to exploit things. But there was one system that was running VoIP traffic. And the person who owned that system, who was the boss of everybody, was like the CIO. It was a smaller organization, so he didn't have that title. He was the IT manager. He didn't want MFA on that system because he was afraid if you put things on the system, it's MFA, it's going to disrupt my calls. All of his calls have people speaking credit card numbers on them. He didn't want the MFA on it. So the pen tester, his exploit was, hey, you were really good on this MFA control. I got hit with Duo everywhere, except this one system. I logged into it and I found out this is the VoIP server and I can capture the streams. And we're like, dude.
Yes. You got a right to be smug.
Yeah.
As long as you weren't the IT manager.
Yeah. Yes.
So in that example, you're talking about penetration testing, the intent of it. Would it be safe to say that it would be a similar concept as a proof of concept, or some type of, hey, here you go type of thing?
So a pen test is typically a organized formal activity. And so if you look at this here, it is a formal activity that you are given consent to do in writing, and you explain the potential outcomes of that. And then you begin by doing reconnaissance discovery, and then enumeration, vulnerability assessment. Then you do some execution on that, try to exploit the vulnerabilities, you document your findings, and you share that back with the organization.
Okay.
So I introduced another concept here, and it's not in the ISSA-PS. It's called the cyber kill chain from Lockheed Martin. It's very popular with all the cool people who are in. So you should look at cyber kill chain and know that people will constantly refer to it when you get into a more sophisticated crowd. And it basically just, it's a well-documented framework with nice graphics. That's the other thing, it has nice graphics. So if you're trying to do a presentation to somebody, you want to show them nice graphics, you can get that from this.
Okay,
Yes.
I want to understand a little bit more about what you said concept. Do you mean outlining how you can exploit the vulnerability and I'm asking you that.
I have 14 minutes, so you can, let me just keep moving.
It is a proof of concept. It's proof to the IT manager that having one system without MFA, you can get your whole system.
Yes.
It is
You
like,
don't need the payload to show that necessarily.
Well,
Oh, but they'll bring it out and show it. They usually show evidence of how they exploited it. They show the exact precise method they did it, and they tell you exactly what set of factors allowed them to do what they did.
And I will say I work with pen testers who were not allowed to go that far, so there is.
Yeah, but most of the ones that I've worked with, they understand where the critical assets are and not to damage them, but they're supposed to go as far as they can.
Right.
Okay, so I need to keep going though.
Yeah.
So breach and attack simulation, it is in the book. As basically automating some parts of pen test. There's an assumption that pen testing requires a human actor. Tools are not good enough because there's a certain synthesis of information that only a human can do right now until AI takes it over. Pen test categories, you should know these very clearly. White box, attacker has detailed information. It's just what it looks like. You can see transparently, like this is the environment, gives you maybe even the source code, right? I know exactly, I can look at and find all kinds of stuff that I can try to hit. Gray box, you get partial information, and part of the reason why you see gray box pen testing is because doing black box pen testing is very expensive. And there may be some parts of the system that if the attacker knew, then they could take a different path and they could quickly find something, but they might not find it if you didn't tell them. So you give them some information. Black box testing is basically, I just want to know what could happen based on what everybody else knows. Like, I know that, you know, the key to access the system is like on the internet, but nobody else knows that. So why don't you attack it, right? We'll just see what happens here. So black box testing, you have no knowledge. It's completely like the pen tester has no knowledge.
You, just as a comment here, most pen testing organizations that do black box testing already understands, like they've seen a gajillion architectures, and they're going to figure out that your internal architecture in about 15 minutes anyways.
Yeah, because they're all the same.
They're all the same. There's like 2 or 3 variations on the pattern, and
yeah. Active Directory, you have all the permutations of that. You have domain controllers, you have ADFS, you have like integration points, you know all the stuff that you could potentially. So pen test has a differentiation between internal and external. In the PCI world, your external is basically hitting a known list of IP addresses or web applications from outside. Usually it's an asset, a web application or some kind of information asset. They have a process called ASV, Application Scan Vendor. Not sure if it shows up in the test. That's more like a continuously assessing system that runs on a schedule, and it has a prescribed set of checks that it does. And so ASV systems, it's specially authorized by PCI just to basically make sure you're not putting stuff that shouldn't be on the web, you're not putting insecure protocols, you're not putting, you've patched your operating systems, you know, all that basic stuff. But external testing coming at you from the internet, internal testing tends to be segmentation zone to segmentation zone. So most organizations do not have a big flat organization. They have parts of the organization that are firewalled or separated from other parts of the organization. So internal pen tests typically are testing boundaries and inside of boundaries, but it's inside, not on the internet. Blind testing, you start with limited information, but the defenders know what is happening. So the defender side of it is as important as the pen tester side of it. One of the things that sometimes you will do with these is a double-blind pen test. You're testing the system. You want to see if the defenders even notice. Do they know what you're doing? Beyond Trust, with the Okta breach, Beyond Trust proved that with the double-blind testing, they proved that they could see when somebody is trying to exploit, somebody's trying to exploit their environment. They saw it, they noticed it, knew exactly what they were trying to do. They knew where it was coming from and contacted the organization that had leaked the data, right? That's pretty good. That's outstanding. Most companies are not that smart.
Or quick.
Or quick. Yeah. And they complained. We talked to Okta, and Okta didn't even respond to us for 2 weeks. That's because Okta was probably going like, oh God, what is this? Like, how did this happen? Like, somebody figure out where this is coming from. And I guarantee you there were a whole bunch of very scared security engineers running around trying to figure out which system was the source of that data that went into that breach. Pen test methodologies. Just higher level, OWASP has a web security testing guide. OSS TMM, it's an open source methodology. For virtually everything that you do, somebody will have a protocol for you to do it, and that is really slick. because it means that anybody could, well, you need a little bit of information and training to become a pen tester. But if you want to create a security policy, if you want to test a website and you want to like learn it, you can find information out there that's very detailed about what you do at each phase, how to craft your deliverables, what is included, what is not included, what kind of consent you need to get, you know, all of that stuff. They may even include agreements that you could give your customers. PCI DSS, they have a supplemental on pen testing, but generally speaking, PCI isn't heavily prescriptive. It's basically, you need to have a qualified, no specification as to what it is, but a qualified pen tester, somebody who's carrying around a credential, external to your organization preferably, who is executing those tests on the environments. If you do that, you've met the requirement. And then NIST 800-115 also has a guide on this. Log and event management. The big thing here is SEM, Security Information Event Management, or SEM or SEIM. I'm really confused. There's some terms that I've never been able to differentiate, but they all mean the same thing. Log data is collected, somebody looks through it, correlates some stuff, and then produces an event that somebody needs to respond to. That's generally the idea. There are systems like Google Chronicle. It's a SEM. I've seen people use Splunk as a SEM, but I don't know what kind of plugins it has for that. Splunk is sort of like a place where you just dump all the data coming from systems, right? You can create events and reports based on transactions that occur within that log data, but then SEM systems and systems that are designed to ingest that specifically to correlate security events, those are usually fairly special systems. They advertise themselves as being for that purpose. You have to do things like protect the integrity of that data. So if you are collecting log data, but somebody can figure out how to turn off that system that processes and sends the log data, then they beat you because they can do whatever they want if they've disabled security logging, right? If they can go into your SEM and delete the data that was collected, then they beat you. So integrity, signal noise ratio, a key term. If you give somebody, I think the target breach had this dynamic. The Mandiant system was in place, but it was generating a lot of noise, a lot of potential things that were wrong. They didn't have the time and the energy to go through all those events to differentiate what was valuable and what was not. So they missed very important, very clear information that was in that dump that they were getting from that system. So low signal, high signal to noise ratio, is it high? No, it's low. Means I'm getting informed about things that are valuable. I'm not getting informed about like every time somebody logs in or things that are completely okay, right?
Hand over here.
NTP, what's that? Oh, yes.
I was just going to say passwords show up in those logs all the time.
Passwords can show up in logs.
So
yeah,
make sure that you're like protecting that accordingly or
there's
telling people to change their
concepts in logs
passwords.
about verbosity. Verbosity is going from like, hey, only show me the warnings, only show me the errors, show me everything. So verbosity is used for troubleshooting. We've seen people turn on very high levels of verbosity and things when you have events happen in a system. There are instrumentation systems that you can spit an event to a log, and sometimes you'll see keys and stuff show up there.
I was actually thinking more about the people who put their password in instead of their username, and that's now transmitted plain text.
That's a particular kind of thing.
Yes.
Yes. So just like you can go to a website and accidentally misplace some part of it and end up somewhere else where somebody's trying to, you know, like sell you something or exploit you or get you to buy Viagra, whatever it is. It's like you can do that. When you put the wrong information in the wrong place, you've disclosed it. So parts of TLS, for example, aren't encrypted. You can put things in TLS that people can see. So.
Wait, so are you talking about like a fake login portal almost? Or?
So
No.
let's say that you go to a website and you try to log in, but you put your password in the username field. They may log your username and not your password.
Or Windows, same thing. Instead of your Windows username, if you put your password in the Windows username field, Windows will log that. and it is out there somewhere.
So some smart systems, the logging system itself will mask it, or it'll sometimes try to identify. Anyway.
It's not always great at that.
No, it's not. MD5 is a hash. Know the difference between hashes and, or one-way asymmetric and symmetric encryption. So know the difference between the three. Oh, yeah, I put this in here. This was a complete sidebar, and like I've got 3 minutes. But NTP was one of those things that time-based information becomes important. If your SEM is recording the date and the time of all the stuff that occurred and critical events occur, but the data that's feeding into it says that for this one system it was last week, and for this week it was this week, because the system time is off, and the log data being sent is wrong. You may miss a correlation. You may have something that occurs that you never even thought of. So somebody could set the system time to like 1900, right? Let's say that that's a functional thing you could do. The event data may be so far back that it's not going to show up on a dashboard. And they're doing all the stuff that they're supposed to do, but they tampered with the system time, and you'll never see the data. Theoretical possibilities, we could argue about this one forever because you'd think that systems would be smart enough to beat it. Systems are only smart enough to beat everything that they were trained and reprogrammed not to be beat on. So, yeah. Code review and testing. I wanted to mention this. Fagan inspection is it's in the book. Planning, overview, preparation, inspection, meeting, rework, and follow-up. It is a formal process. It is a painful process. The idea would be that in this formal process, you find these issues, and then the people who created them remediate them, and you go into a meeting and you review it with a group of people. That's the complex formal process. Think that you would use this for, you know, Department of Defense or something medical or something, you know, very sort of like very sensitive asset. But then no Git flow. So I put this picture here because this is the simplest picture I have ever found to show Git flow. If you search Git flow on the internet, you'll find all kinds of pictures, but this one is ridiculously simple. The idea is there's a stream of consciousness in your throat. I'm going to change something. I fork that stream of consciousness just for a minute and make a change, and then I'm putting it back into the stream. And when I do that, somebody else looks at it. Some system, like let's say you have an assessment, like you have a set of assessments that occur in your code. That occurs. And then a human, another person, a colleague, and the source control repository systems, they'll enforce this. This is a fundamental control to all code development, is the idea, this Git flow idea, that between the branch that you created and when you merge it back into the stream of consciousness with everybody else, somebody else looked at it, somebody approved it, reviewed it, you at least had 2 eyeballs on it. In this world of everything as code, when you embrace this methodology, if you make a change to the way that something is deployed in AWS or Azure or any other cloud provider, you make a change to an application, its configuration, all of these variables stored in code, behind that Git flow process, you at least have 2 eyeballs. You can make that Git process more complicated. You could say there's a particular person who has to approve, or a security person, or 3 people, or 2 people, right? You can make it as complex as you want, but the idea is it doesn't go back in for everybody else until something has occurred that you wanted to occur. And you heard the concept of infrastructure as code. That is the basic idea that you can write real code, TypeScript, Java, .NET, Python, and it defines the resources created in the cloud or in systems. You can, with policy as code, and there's this tool called Open Policy Agent, which kind of like helps you with it. You can enforce the policies of things, so it allows you to abstract individual configurations to like a policy. You can, your configuration of the system's in code. Your environment is defined in code. One of the things we like to sell at work is the idea that your dev environment is in code. Because one of the complicated things, if you have a system and you've never set something up before, you need to configure a bunch of stuff for it to work. If you put that in the code and you're working with a system that'll just build that environment for you so you can develop, you can get in and out quickly. You can bring in a new developer. They get in and out quickly too. So people save a lot of time, and the configuration of that's in code. So the next person comes along, if there was some tool that had a vulnerability and needed to be updated, Git flow controlled that update, and now everybody's working off of the same stream of consciousness, right? So DevOps is the idea of using pipelines, using code to deliver things. So your code goes into something that processes it into an output, a result. App testing concepts. Know these really clearly. Static application security testing. So
Hey, Paul, I'll cover this code stuff next week with software development. So maybe you want to skip ahead to synthetic transaction and monitoring and interface testing?
You cover RASP and IAST?
Yeah.
Okay. How many slides do I have left? Since you asked me, I get to ask you. Not many.
About 20.
Really?
Yeah.
Dang it. Synthetic transactions?
Yeah,
Want to know what
I'll
these
cover
are?
that.
Basically, people do stuff, and you can simulate people doing stuff. Lots of tools for this. Selenium is one of these tools. Open source, you can script the whole interactions of a website, and people use it for testing.
Skip all the way ahead to slide 48, because I'll cover all this next week.
Okay.
So go to common software vulnerabilities, and then
Fuzzing,
I'll cover
mutation
next week.
versus generational. Mark is now pushing me. Mark,
Yeah.
do you have some reaction?
Because you're already over.
I know. I was trying to be disciplined about this.
Yeah. So, but
People are the problem and people have questions.
People have problems when people have to stay late. Okay, negative testing, I can skip that. What else you got, Mark?
test coverage,
Test coverage?
yeah.
You're gonna cover that?
Yeah,
Oh, I don't know. All right.
not this, not yet. I could add it, but
Yeah. Okay, these are the OS top 10. It does change. There's the latest update. Information Security Continuous Monitoring System, NIST 800-137.
I'm not covering it, so go into it now. No.
Yes, you should know this.
Yes.
And I would say if you don't have a list of tips and tricks to start creating your own database of resources, that you should figure out how you're going to organize, right? Because the only thing is they're going to keep growing.
Sure.
Yeah.
What we use as.
All right. So I want to commend the presentation team today. We started at 8:30 promptly. We ended at 12:34, which was very nice. We had a high level of collaboration
Yep.
between us. That kind of thing.
Yeah, yeah.
Did everybody online, did you have any questions?
But I do have a comment. I'd like to thank you for the real live scenarios, right? Because that helps us understand the technology behind all the words. So thank you. Great presentation.
You're welcome. Hopefully that made it more interesting, right? Because like besides me droning and looking at my laptop here with my slides on it, like people have to do something to make this interesting, right?
Yeah. There's enough of the droning when you read through this material. So, yeah.
All right. Thank you. We'll see you next Saturday.
I would like to make a pitch for those people online. Please try to join us next week for the final one. It's more fun with people in the room and to see you like nodding off rather than hearing the snoozing on the, no. Please come join us.
I will bring something special for the snacks next week.
Ooh.
Yep.
Yep.
Do we get a hand?
Nope.
Nope.
'Cause I don't even know what it is.
Is it WebEx again next week?
Yes, it'll be WebEx again. What we learned is that this presentation system works best with WebEx. So we're just going to adjust.
Yeah. Okay.
We're taking picture time? Okay, online. Well, we're getting ready to take pictures. Thank you for attending. We'll see you next week.
Now is the time, so leave the area, I'm not going to be a picture that will. All right.
Yeah.
Yeah. 1, 2, 3. Awesome.
Thank you.
You guys up here with like a
Yeah.
science background?
Yeah.
maybe in front of the podium, and I won't get there, but I'll get a slide. Okay.
That's right.